Hello, everyone. On behalf of the Industrial Fabrics Association International, welcome to the webinar, Cost Considerations for Prototypes and Production. My name is Magda Ronigan. I am the National Program Manager for IFAI's Makers Division and also today's moderator. The Makers Division supports the sewn products industry and any machine operator in the industrial fabrics industry. As a leading international trade association, IFAI helps members thrive by providing education, marketplace presence and trade shows, networking opportunities, resources, and recognition. So if you're new to IFAI, we invite you to join our vibrant trade association. Before we get started, I'd like to go over a few items so that you know how to participate in today's event. You will have the opportunity to submit questions to today's presenter by typing your questions into the questions box of the control panel on your screen, and questions will be collected and addressed at the end of the presentation today. This webinar is being recorded and will be available to IFAI members in the future in IFAI's webinar library. And a PowerPoint will be emailed to you after the presentation panel today. So now I'd like to introduce our presenter, Chad Miller, Director of Contract Manufacturing at American National Manufacturing. Chad began his professional manufacturing career 20 years ago, and in 1997, Chad and his father, Craig Miller Sr., started a contract manufacturing business where Chad was the managing member. In 2010, Chad and his father merged their business with American National Manufacturing, where Chad was named the Director of Contract Manufacturing. And together, they have led the division to record growth with over $3 million in annual sales. Chad has over 20 years of experience in designing, engineering, and manufacturing products in the medical and consumer sleep system field, inflatables, water bladders, foam products, and medical and non-medical applications for the aviation, recreation, marine, and safety industries for clients such as Medtronic, 3M, Baxter, and many more. Chad is an inventor, and he has 2 patent filings, which resulted in his creating an entire line of products designed for preschools, hospitals, and other educational facilities under the brand name Happy Child Products. Chad has been the general manager of Happy Child Products brand since its inception over 6 years ago. Chad serves as a board member for the Corona Chamber of Commerce and a state legislative action committee member. In addition, he is certified in OSHA 511 standards for general industry and is also a certified instructor for the Red Cross. So welcome, Chad. Thank you for sharing your expertise with us today.
Thank you. It's my pleasure. Thanks for being here, everybody. We have a lot to go over, and welcome everyone to this exciting webinar. So really to kind of talk about our company, we have navigated many ups and downs in many industries. So to get into that, I want to share a little bit about kind of us, and I know that was a great introduction, Magda, appreciate that. So as we have established and kind of grown our product offerings, our company started back in 1972 with my father and making water beds. We now have these locations you'll see here. One here in Corona, California, which is our manufacturing headquarters. We have one in Riverside, Missouri, which is an assembly warehouse and distribution. And then we have a factory in Tecate, Mexico. So we now have spread our wings across the country and then down south of the border here to help our growth in all of our different products. We have about 200 employees currently. We have over 70 RF welding machines and about 100 sewing machines throughout these facilities. This slide here kind of shows you some automated cutting machines that we've got in our cutting department here in Corona, California. And then you'll see one of our, 2 of our sewing lines here in Corona. And some of the industries that we work in are medical, consumer, we make safety products, we make products in the aviation world, education industry, as Magda mentioned earlier, and then some environmental products. There's many more, but these are some of the top different areas that we're going to talk about that we do here. So going into our equipment, what kind of equipment do we use? We have, as you just saw, a lot of sewing machines, but we also have RF welding equipment up to 175 kilowatt. That's a very high-powered machine. Allows us to weld, radio frequency weld a very large surface area. 120 inches by 93 is the old waterbed machine. And then we have all kinds of types of RF welders, such as standard machines, turntables, shuttle machines, automated PLC-controlled machines. So we have a lot of equipment that we have and a lot of bodies that need to learn how to maintain this equipment, train on the equipment, design tooling for it. So that's kind of a broad brush overview of what we do here at American National. So the objectives of today's training is we're hoping that you'll gain an overall understanding of the prototype process. And I will use some slides in some previous trainings that we did to assist with, if you had not had the opportunity to see those, it'll kind of fill you in on that. And then next is the understanding of the 3 different types of research relating to product development. And then learn what efforts may be required for each step of the process. Learn factors that affect the costs of R&D. Identify cost centers both internally and externally. And have resources for assistance and information. And one of the resources I'm glad to share today are ways that you can offset some of the R&D costs. And then one of the things also to think about is as we present this, a lot of my work is relating to companies hiring us to help them, if they just have a concept, to develop their product from their brain, what's in their mind, and actually have a result in an actual product that's ready to go to market. But some of you may actually do R&D internally for yourselves. And so I'll kind of touch on both aspects. Internal R&D for your own product design and development, as well as external where someone may be hiring you to do that. So what I have here is a slide that shows the actual prototype development process. And because we're an FDA registered medical device manufacturer, these are what the FDA has determined in ISO, like ISO 13485 certification that we follow. And the top row you'll see here is in blue. So the collection of design inputs is the first step, the first phase. Second phase is engineering design review, because as you collect the data, whether you're doing it internally or externally, this comes from somewhere. And there may be a lot of unknowns. And that's what this engineering design review takes, what the inputs were, looks at what the design is in engineering. Does this fit? Does it work? And we'll get into some more questions later. And then that's where you come in and work on the proposal for the prototype, because now my customer expects me, or my boss expects me, to present the proposal for what this development of the prototype is going to cost me. So we're going to look at how and all the factors that affects the cost of developing this prototype so we don't forget anything. Now then it drops down here to phase 4, which is the prototype development. So we've gone ahead and done these first phases. Now why are these in blue and these are in green? Because typically when a company hires us, these blue boxes are costs I assume. I don't charge clients for the meeting with them, gathering the inputs of data, having a design review meeting with the engineering department over what this product's design is, determining, is it 80% designed? Do I need to put a lot of horsepower in engineering to try and fill in the gaps? And then the next one, the actual prototype, the proposal for the prototype, as you see here. So we don't charge for these first 3 phases. Where it turns green when I go to finally develop the prototype, that's where we start charging our customers. So what we do is we present, and we always recommend how do you properly or effectively do a proposal for your customer on what you're going to charge them for the process. So to do that, we first have to understand that process, which is what you see here on the screen. And then the next phase, after we've developed the prototype that you realize is going to happen, is you're going to go to the evaluation of the prototype. This process of developing the prototype could have taken anywhere from a month to 8 months or a year even. And then evaluating the prototype, we're going to learn today that there are internal things and external things that are going to happen or require to happen for the full evaluation of the prototype. This takes time. And then almost always there are design changes or improvements to the original prototype. Again, this is another phase that you're going to want to make sure that you offset somehow with charging your customers, or if you're doing this internally, you got to make sure you leave time and money and resources allocated to design changes. And then verification of changes. You've had these changes that may have been made over this original prototype. We have to verify that these changes didn't affect something negatively in your product design, because your product could be part of something else. It could attach to something. We want to make sure that the changes that were made didn't affect anything, and we lost some ground there. And then lastly, product validation, and we're going to explain that here on the next slides, validating that the product is going to meet all the requirements that we captured up here in this first section. So moving on, let's talk about the types of research and development, and this is as defined by the National Science Foundation. So there's 3 degrees, well, there's 2 degrees of research, and then we'll define development. So first is basic research, and it says this research aims to understand the subject matter and requires building a basic level on knowledge relating to it. The finding of this research may be of potential interest to the company and does not have much practical or commercial application. So an example of basic research is if someone contacts me and they're asking me to build a product that's going to go into a zoo, for example. I'm trying to cover a zoo or do something or build something that's going to be in this environment. I may need to look at and learn about the basic environment of a zoo. I have no idea. I've been to one before, but there might be specific things I need to research about that. No, it might be a product that goes into electronics. Maybe a product that goes into aviation or underwater, and then there's some requirements that they have in that. So it's kind of a broad brush, helicopter level, if you will, research about maybe an industry or something about the environment. Then there's applied research. Now this is more specific and has more directed objectives. It aims to determine the methods to address specific to a customer or industry or the needs or requirement. And these investigations are focused on specific commercial objectives regarding the products or process. For example, if we're trying to shade an area, or I'm trying to make something that lifts something, or I'm trying to deploy something that suppresses fire, and there are certain heat elements or constraints of the environment it's in, this is where it's now applied research. So there's a basic level of research, and then there's applied research that may need to be done on a project. And then, of course, you have the development. So when the findings of the research are utilized for the production of specific products, including systems, materials, and methods, it is research that generates requisite knowledge and design for production and converts them into prototypes. So now you're taking what you've learned in your research, whether it's a material requirement or maybe a strength or burst test of something or a load capacity. And I can share examples right now. This is the 50th anniversary of the waterbed, and our company is involved in a production of a new waterbed, and we were just literally on the phone determining what kind of tests, when you have a 1,200-pound waterbed on a frame, what kind of shear force and load testing we need to do. And that's kind of, I did some basic research and some applied research to help in the development of that, and we're currently in the works of developing this new clean green frame that's going to be used in the launch of this products that'll be later this year. So I practice this stuff on a daily basis at our company here. So one of the major factors affecting the costs of R&D is knowledge. Knowledge of the industry, for example, like I mentioned earlier, medical. We make a lot of medical products. We're very, very familiar with FDA requirements and regulations, and the environments of our products are used in hospitals. So we have to be aware of the environments in the hospitals. If it's a hospital, if it's a home care or a nursing facility, or maybe, someone's needing a medical product that they're using while they travel. So we're very aware of that industry, of the product. Have I ever made a product that does or did or can do what the customer is asking? How confident are you in your knowledge of the product? And then your knowledge of the regulating authorities and the requirements of them that are going to be imposed upon you at some point in the process. Just like the example I just used, I know that a metal product that we would use for a bed frame for a mattress is going to be painted, or it could be powder coated. If it's painted, the Consumer Product Safety Commission is going to require me to test for lead paint. They don't want lead in the paint. So knowing all these things, your knowledge of these things are important, because if you don't know them, there's going to be significant research that you're going to have to do to find them out. That, of course, increases your costs, and you got to pass that. You got to assume that cost or defer that cost. You assume it by realizing you're going to pay for all the resources to get the result, or you're going to defer that and charge your customer for that part of the process. And then your knowledge of the market. And one thing that people sometimes get confused on is what's the difference between a market and an industry? So for example, we could be talking about a product. We make products for preschools. So the market's actually the industry is the early education industry, but my market are actual preschools. However, I can also sell through dealers. So the market I might go after are people who sell to preschools. So what's your knowledge of the whole process of the product? Because if you're doing this internally and you're developing a product for a certain industry or a market within industry, your knowledge of that is going to be very helpful and determine where your costs, if they skyrocket or if you are aware of them. But that's a really big thing that I think people overlook commonly. And then the next factor is your talent and your team. So do I have the right people, whether it's the people that are going to make tooling or the people that are going to make the product or the right engineers? If I don't have an engineer that knows inflatables, it's going to be a struggle for me, because when you design something that's a solid, like a wooden block or a pillar for a building, the beams that are used there are solid and they hold the roof up. Well, when I'm making inflatables, my drafters, my engineers need to understand that when I put in, if I make a square box and I inflate it, it's going to look like a beach ball. And if you don't have a drafter or people on your team that understand that we're now putting an I-beam that holds the roof from blowing out, if you're doing a tension roof that's got positive pressure in it, they're not going to be very successful, and it's going to take you a lot longer to complete the product's design because they don't have that right experience or knowledge. So an engineer that built buildings isn't a very good engineer for inflatables, is I guess the point. The next is, do I need to outsource any talent? Maybe I got to find someone or hire someone. So you got to make sure that if you don't have the right team or you don't have all the right skill sets, that you'll have to outsource that, and there's a cost that comes with that. And then materials, machinery, and manpower. All right, are all the materials I'm looking for this project easily accessible? Do I got to fly somewhere? Do I got to have air freight in parts from somewhere else in the world? Do I got to meet with a local vendor or a vendor that's in Florida and I'm in California? Do I got to call 4 or 5 vendors? Do I have the right machinery or equipment? Do I have to adapt the machinery? Do I need to have my sewing machine company that services my equipment come out like we did recently on a project where I have plenty of equipment, but I didn't have the right fixtures, attachments, or tables for this product? So there's things like that you have to consider, what kind of changes I have to make to that. So of course, do I have the proper equipment? Like I mentioned, machines, jigs, tool aids, or test fixtures. Is there room in my workload? Do I currently have the ability to take this project on and allocate the resources to conduct it in the time frame that's desired by my superiors or by my customer? And then product status. The one important thing to realize is, I kind of hit on this earlier, how much of the product's design or engineering has been completed. I have some clients who have a full technical package and they've got the bill of materials completed. They've got the calculations of use. They've got, the dimensions, everything figured out, the radiuses. They've got the thicknesses of the materials they want, the height they're trying to get at, the loads and tests required. And then I've got the other customer on the complete other end of the spectrum, who all he has is an idea in his mind, and I have to do a lot of work to extract how this product looks to him. And basically, I kind of need to 3D print what's in his mind somehow, and I've got to gather the information to get that out of him. So that tells me that project is going to require a lot more administrative time on the front end of it. So determining where the product is in its current design phase is really important. And that design phase, the phases I showed you earlier, kind of tell you, are a little map of that. And then we're going to talk about phases of product development. So phase 1, as you saw early in the slide, is collection of design inputs. And this here is kind of a sheet that I've shown in previous webinars. This is all the information, a good start that we need to gather. The industry that's used, its intended use, its dimensions, any known hazards, a timeline of design, where the design is, kind of piggybacking off the last slide, how far they are in the design, what my estimate is when I can have a quote, if I do the quote and they approve it, what my prototype timeline would be, and then after the prototype's developed, what kind of tooling time. Usually it takes 3 weeks to get a tool done. So there's designing of the tool, and people don't realize I may have to have my drafter spend 4 or 5 hours just to make 5 sets of tooling, a piece that welds a valve in, and then a piece that does this, or a jig for a sewing machine or something. So there's a lot of work that goes into prepping the tooling, because a product can't be made in production without tooling usually. And then there's a production process, and I'll get into a slide later that explains that. And then down here we have quality objectives and requirements. Its fit, form, and function, or its application and attributes, and how it's supposed to operate. Down here, a section for code compliances, if there's any statutory, regulatory, safety, fire, or any others. The customer may not know this, or your team, if you're doing this internally, may not have any idea of what that is. Over here, basically I have an area for 3 main material requirements. Like a lot of times we use foam, and we use fabrics or fibers or materials like plastics. That would go here. So this gives us 3 different areas to document if the customer knows. And some may not know. And if they don't, that tells you there's going to be a lot of hunting of different types of materials and their ability to perform in the environments that they're talking about here, in the industry used and the intended use of the product. Then down below that, design inputs from the customer. They may have a website. They may have a flyer. They may already have the material specs. They may already have a way to know how to make it. If it's a sewn product, they've already sewn a couple up. They've got templates and patterns. This helps you reduce the time that you're going to need in the process of product development. They may know their packaging specs. They may not know it. And then they may know the quality requirements, performance requirements. Does it have to inflate and deflate 10,000 times over its life? Do they know the test methods that tell you whether or not it's meeting the requirements or the quality objectives? And then their accepted quality level. If I make 1,000 parts and I test 12 out of those 1,000, if 3 are good, do I pass? So they may or may not know that. So there's going to be work on the quality side you're going to have to get people engaged in. And then the packaging. Do they have a spec or not? Is a product put in a package? Is it folded before it's packaged? Does it have a separator in there? Does it have to have a label facing up? Does it have to have a barcode on it? Does it have to be printed with the customer's website or a lot number or a code or a date of some sort? So this is a very thorough sheet. And again, this is something we don't charge our customers for, but there's a cost to us doing that. So keep that in mind. And I put a note here that it can consume as little as 1 hour of time, but it can also take days or even weeks. Depends on how much of the required information is known. Things to expect in this process is expect several meetings to be required to get it completed. Expect that there's going to be missing information, and that decisions will need to be made in order to get that information. Other resources will be needed. We probably are not going to be able to do all this in most cases, at least in my experiences. We need to gather additional resources, whether it's getting vendors involved or getting other engineers or other product managers involved, another department person involved. It usually is the case. And we always expect delays. Someone's on vacation. Someone's out of town. We can't get that information. There's always delays that cause the product timeline to be pushed out. Phase 2 is the engineering design review. And we'll just go through this quickly. This phase is documented. It's comprehensive. It's a systematic examination of design, because we're trying to, and you see the bold words, evaluate the adequacy of the design requirements. And then you see the next bolded word, evaluate the capability of the design to meet the requirements. And then you see the next bolded word, and to identify problems. We're trying to figure out the problems as we're designing it, looking at it so that we can address them. And once a product gets it down the road, it's more costly to deal with. So what are the big questions? How much time will all of this take? What resources do I need to complete this engineering design review? Do I have those resources internally? Things to consider is the cost of this process. It is difficult to determine. So the more work you can do and the better understanding that you can have as to where this product's design is. Again, it could be a concept, simply a concept, or it could be something that's 20% figured out. The important thing to remember is getting as much information as you can, because the costs and time requirement that we're going to be burdened with is all going to be whether or not we make any money on this project or whether or not this is something I'm just going to accept as part of my business operation. These are really important information to have to make those wise decisions. So let's look at some cost categories. We just talked about some examples of some administrative costs. There's going to be your time involved. You might have to get accounting involved because they have to set up a customer code or you know, who are these people you're working with? You know, are they going to be able to pay the bills? Are they going to accept my proposal? So accounting gets involved. Your purchasing department may have to contact vendors, get samples sent from them. It may be domestic, it may be foreign. A lot of work might come in. There might be 3 or 4 versions. Oh, I want product A, B, and C. I want one that's fire retardant, one that's not. I want one that's this thick or that thick, or I want one that's laminated or one that's not. And then engineering. Of course, engineering is going to get involved, and then there's quality people that are going to be involved. So when you look at administrative, there's a lot of administrative resources we're going to need to allocate in this process, and each one of those comes at a cost. And then there's direct. So you have administrative category, then the next is direct. So there's the labor that's going to be involved in actually taking stitch to fabric. There's the people in the cutting department. There's people in the inventory department that's going to pull material. There might be sub-assemblies. Maybe I have to make some tubing. I got to have a guy go out and grab 25 feet of tubing and grab some connectors and make some sub-assemblies. And then give those to the assembly department. And then the assembly department is going to have a touch point on it. And then maybe it goes to the printing department. So then they got to mix up some ink, you know, because they want a pink color or a blue color. So now my graphics department is going to have to design a color ready artwork, and then we've got to burn a screen, and then we've got to go and mix up the right ink on the right, you know, and the right ink's got to go on the right fabric. So there's a lot of detail that goes into all the direct labor costs. Of course, there's utilities. I got to plug my machine in and have air to it and power. So there's utilities that are going to be consumed, and then outside processes. Maybe I don't do silk screen in house. Maybe I got to send out. I don't do embroidery, so I got to send out the embroidery. That's going to cost me. Someone's going to drive it to embroidery. I got to put it in the mail or whatever it's going to be. So there's direct costs that are related to this product that I'm making, and I don't want to forget that I got to calculate the time and external costs I'll have, both internally and externally. Then, of course, there's your category of non-recurring engineering charges. We call them NREs. There might be tools, manufacturing aids or jigs that I need. There might be some drawings that have to be created, whether, like I said, like an artwork or a screen. Packaging, I might need to design. We actually do our own packaging here. We've got a packaging machine. I might need to draw up a right box size. So non-recurring engineering is designing the packaging, you know, of what it's going to look like. Is it pretty? Is it a brown box, a white box with print, a print with label? So there's all kinds of non-recurring engineering that goes into packaging design. Some customers already have that figured out and some don't. They rely on us. And then we have some that have some of it. They know they want a product ID or they want a picture of their product on the box. Okay, but does it have to have a UPC code on it? Does it have to say box 1 of 5? Does it have to be branded or a certain configuration because they're going to sell to Walmart or Target and they require a barcode with a certain code on it, code 39 or 128? So there's all that has to be figured out in the R&D of a product. And then you have indirect costs like your company overhead, your supporting staff. You might have project meetings or follow-up calls you have to make. Or I might have to make some alterations to a production line. I made body bags one time. I didn't make body bags, so I had to take a whole area of my building. I got to clear it all out, and I got my maintenance folks, and I got my production manager, and I got my facilities manager, all moving equipment, unplugging things, moving things. So you have to make sure that you don't ignore that if you're taking on a project or a product, whether you're doing it yourself or for someone else, you got to realize that you may have to make alterations to your, maybe you got to run power or run a new airline drop or something. So that's something to consider when you're considering taking on a project like that. Going back to the next phase, we're in phase 3 where remember, we still haven't even done the proposal for the prototype yet. We have to learn all those first 2 phases first. Now I'm ready for the proposal. So creating a prototype proposal for a client for product development, this phase takes into consideration the previous 2 phases. And at this time that we expect there's a great understanding of the overall product design and what it's going to take to make a prototype. So recommendations of this is be sure to get input from your department managers that are going to be involved. So get them and have them look at your project and determine how much of their time or their employees would need to be involved to properly do this. And then consider the cost categories that you just saw. I'll bring them in here. So remember those categories. Consider costs of the material handling and freight. Remember, if you're going to get some material, maybe you need a roll, maybe you need 50 yards of material, maybe your vendor requires you to buy 25 yards, or if you get 6 yards, they're going to require you to have a cut charge. And then you have to freight that to you. So those are all costs in your project. Be sure to consider those when you're quoting out a project to a customer. And then phase 4, here we go, we're going to finally develop the product. This great thing I used on a previous webinar here, this shows our internal process. Going clockwise, the top is the inventory department. These are all the internal processes as I'm developing the product. And remember, we've already gotten the material, contacted vendors, paid their freight to have the material. We got all of our zippers and snaps and buckles and buttons and webbing and all these things that we needed. We're past that. And now here you're talking about the inventory department that has a touch point. It goes to cutting, which then may get RF welded. Then there might be sewing. It may bounce back to RF welding after sewing. Then you have the assembly department that gets involved. Then you have the printing department that potentially is involved. Then our quality folks get involved. And then packaging. And then the red dot here, that's where everything here was internal. And then the minute it gets shipped, so here's where it goes from the last quality step before it hits shipping. And this is our last step before we don't ever want to ship a product that's not good. So that's why it's red. That's the critical point. It can't leave here without knowing that it met all the requirements. So all these processes, all these departments, there's people involved. There might be 3 operators that are involved. There might be 4. There might be 1. And in some cases, I don't even use RF welding. I would go straight from cutting to sewing. So you have to know how many touch points and the time is required for each one of these departments that are involved in this project. So give them our department managers always love when we respect them and their time and saying, hey, I'm working on this project. This is what I need your part to do. Take a look at this and let me know. They really appreciate that. And they tend to act much more favorably when the project, assuming we get the project and it's a go, they really act more favorably on getting involved with us on the project and getting things done. They're aware of it now. They're quicker to respond and the results are better. So here's a tool that I wanted to share with everybody. This is part of our direct process costs example. You'll see here, you would put the product title here, and then I'm typing up all the operations. Here's my description of the operation. So I'm cutting this material, I'm punching a hole for the valve, then I RF weld the valve, then I RF weld the bladder up, and then I remove the tear seal because it seals and cuts at the same time, but I got to remove the scrap later. And you'll see how we do it. We type in the minutes that manager said that would take, how many people are assigned to that process or that step of the process, and how many operations it is. For example, if I'm putting snaps in, I might put 1 snap in 4 seconds, but I got 25 snaps. Then I would put 25 there and put the time in minutes here. And then our software automatically, our Excel spreadsheets automatically calculate the labor hours because that's the end result is how many labor hours actually takes place. And this is for production. I do use the same sheet when I do product R&D as well. It might take hours or 2 hours to do something. And then the next area would be sewing. So cut the top and bottom sheets. You see that I put in here 1/4 of a minute. It's 1 person, but there's 2 operations because I have a top and a bottom sheet. You can cut a top sheet in 1/4 of a minute, but then I got 2, so that accommodates that. Cut the zipper to length, 0.1 minute, and then 1 person, 1 operation. So you see it's calculating that for me. So this is a tool we use showing the sew on the zipper takes a minute. There's 3 sides, so there's a minute per side. There's 3 operations. So it takes the 1 times it by the people times it by the operations. It spits out automatically my per hour rate for that step. So you can see this can be quite daunting, and having a tool like this to calculate it all, we even dump in here a quality control allocation. It shows the acceptable quality level 6.5 that our customers require. So now I'm making sure I don't forget to charge my customer for whatever quality requirements that he has. If he wants me to inflate, 1 in every 25 parts, there's a cost of that. And then deflating it, packaging it all up, and documenting the pressure levels. So we actually have to have some sort of allocation of what degree of quality time is put in. And it shows you it took 0.4 minutes with 1 person but 1 operation. And we're putting that into our quote here. And then packaging. Don't forget about packaging. You got to fold this up, maybe put a label on it, put a sticker, put it in a bag, tape the bag up, put the bag in a box of 12, and then tape that box up and put it in a master carton with 25 parts in a master carton. That takes time. So when you total all these up, here's an example of a per part takes me 0.1475 hours. That number gets dumped down here, and then you have an efficiency. Why do we have an efficiency? Because I might have a good idea of what it takes to make the product, but we have lunch breaks. People get up and go to the restroom. They stop what they're doing and they leave to go get a box from inventory, or they have to leave their station or document something that, a paperwork that's at their station. So we put 80% efficiency, and it ranges from 70 to 95%. If I have a robot doing it, that robot doesn't take breaks. It doesn't stop. It might stop once every 4 hours for a maintenance check or something. But for the most part, it can be 95% efficient. So this efficiency factor takes now my labor hours and makes it now, we went from 0.148 hours, now it's 0.184. We have our labor rates. So now this tells me what my labor cost was just to do this, if that's my labor rate. And again, you can change this based on your labor rates in your state. And this is burden. That means your direct labor plus any benefits you have, plus your taxes and fees and all that stuff, and your fully burdened labor rate. So now you know what your cost is. Now you have a tool to know what your price is going to be to your customer. And then this, you don't see the rest of it on the right side here. It was an allocation of materials. So it has a bill of materials that would be there. It dumps all the price on your materials. So I know my total cost of the prototype. So don't forget your materials. That's what I was just talking about. The methods and which are your steps, what I documented here. Your manpower, what it takes, how much time, how many people, how many operations they have. Your machinery, your efficiency, we talked about that already. Your learning curve. Don't forget that, if you've had someone that's sewn a stretch knit fabric before, there's no learning curve. They know how to take tape edge and sew it to it, or they know how to use a button machine. You're not teaching them to do it. That's where your learning curve comes into your efficiency. And then your quality control. Don't forget that. That's what I put down here. I want to make sure that was represented. Your packing costs, you'll show that here. And of course, you can't calculate packaging costs unless you know what kind of bag it goes in. Is there 1 product per bag? Is there 5 products per bag? Is there 5 bags in a box? Is there a core separator? Is there something inside of it? So box labels, etc. You got to know all that in order to know what your costs are going to be. And then your shipping costs. What's the cube going to look like? Am I shipping a big box of air, or am I shipping it, on a pallet? Now I got to add a cost of the pallet. Maybe the pallet can't be just a standard wooden pallet. Maybe it's a plastic pallet. So all those things are questions we need to have the answers to. And then insurance. If you just did a project that's worth, so say the last project I worked on was about a $4,500 overall R&D project with a prototype completed and shipped. Do I want to ship that $4,500 product without it being insured? Because when I ship it, the carrier is going to insure it for probably $400. So if that gets damaged or lost, I've already billed my customer for it. I got paid for it, but he's going to want his money back if he doesn't get the part. Do I make him go fight the freight company? So don't forget to include putting a value on there. If you were going to have to make this product again, what would it cost? I always recommend insuring it through the freight carriers because freight damage happens. Packages getting lost happens. So don't forget that. So now phase 5. I'll quickly go through this. We have to evaluate the prototype. So this phase includes the internal and external processes. There are specific test methods that need to be followed. It can be lengthy. It may require the use of a third-party outside laboratory to test it. It may be a regulatory statutory test like lead, fire, national fire prevention, phthalates test, a product lifecycle test to determine the age. Can this product last 5 years if it's used 5 times a day? Test to failure, overall strength. Let's test it till it fails and document if it's equivalent and consistent. Expect meetings and discussions. You have to expect that that's going to happen. There are going to be a lot of meetings and discussions that take place in that process. And then the last few phases here, design changes. Like I said, there's always going to be changes. They almost always happen. Then verify those changes and improvements. We talked about that, and ensures the changes or improvements don't have a negative impact on the product's performance requirements relating to fit, form, and function. Examples are like fire retardant additive in plastic. It might affect my ability to weld the material, so it's a slower process now, or it's not as good. It might be a change in size. It may affect the footprint of an external part. Maybe it got too big or now it won't fit in this case or housing. And then product validation. The final step requires test to be completed to determine the product's ability to meet all the requirements. That's validating the product after you've made those changes. There might be pressure tests, third-party testing, pull strengths, burst tests, life cycle tests, all that fun stuff, regulatory tests. And again, you're doing those tests after all the changes or improvements have been made. And now here's kind of an example of a first prototype timeline. This is one that I shared in a previous webinar as well. You can see we started on January 17th. You can see all the milestones that were hit and through this process. And this one was relatively short. This was only a couple of months. We started early, mid-January, and ended near the latter part of March. And then you got to remember that internal process, that's where that internal process happened. And this could, in our factory, take 30 days by itself. So here's kind of a linear timeline you might expect a fairly simple product could take. I've had some take 9 months to a year and a half before. And so knowing all that inputs in the beginning helps you to determine that. So there are a lot of things out there. I'm going to share here a cost offset. When you're doing R&D, whether it's for your own company or an outside company that hired you, there might be benefits that you can capture. There might be offsets to costs that you have. And we have some programs and incentives that are through our state, but we also have some that are federal programs. And I'm going to quickly touch on those. This here is a snapshot of our state's website. Our governor has an Office of Business and Economic Development, as you can see. And there's a California business portal that shows here. And they have an incentives area. We have something called California Compete, and it shows that there's tax credits in your income tax credit available to companies that want to come to California, stay, or grow. So if I'm bringing a new product, like if I make water beds here now, and I have to expand my operation, I got to get more space or another building, or maybe add more equipment. There's some credits I can get for that. And then there's employee training. If I got to bring someone in and train them to do something that we haven't done before, there are credits for that. Down here, you'll see incentives by industry type for advanced manufacturing. There's a full sales and use tax exclusion. I can be excluded if I got to buy a $100,000 piece of equipment. The use tax on that, which in our case would be 7.75%, if I meet certain requirements, I can be exempted from that 7.75% use tax on this equipment that I'm going to buy. Or maybe I got to buy $5,000 of tooling. Down here, you'll see a manufacturing and R&D partial sales and tax exemption credit. So manufacturers and certain research and developers may qualify for a partial exemption of sales and use tax here as well. And then the California Infrastructure Economic Development Bank Clean Center. This is just an example of some things. There are about probably 35 different incentive programs for manufacturers in California. They're really trying to keep R&D, develop, and expand production here. So these are incentives that you should certainly look at in your state. I shared this because this is in our state, and I'm very knowledgeable about them. We do take advantage of them every now and again for certain projects. There's other resources you have, the Industrial Fabrics Association's own website. If you were to go here to their homepage and click the Small Business Center, then you come down here to click on Operations Management. Then down here, there's a great tool. They have all these, if you're looking at automation or workflow efficiencies, sustainable practices. There's a lot of great tools within our own association, their website here. So if I were to click, I'm currently looking at test procedures and equipment, I can click on Learn More. And here I am. You can subscribe to the AATCC test methods. You'll see what that is in a minute. But it gives you access to all the different ASTM test methods and that they have out there. So you can easily access information you currently don't have. And you can, as you see, IFAI members may log in to access in this members only content area. So if you're not a member, I recommend becoming one, because this is one example of a tool where it applies to R&D. Another resource I found in doing some research in preparation of this webinar, I came across a very handy tool. So whatever state you're in, this is a map, and you'll see that it's green, it's got red, and I actually clicked California, which popped up this little handy tool, and this shows me California's research and development tax credits. And this has different, and we don't have time to get into all these today, but the resource I want to share with you, you can actually navigate to this website, which I'll share with you in a moment, and it shows you what they've adopted and what they allow and kind of the rate and what they have access to. and what their definitions are. It's a great tool to click on your state to determine what's available for you. And I found this through an organization called Intrepid Advisors, and they're an R&D tax credit expert firm. Their information is down here, and you'll be able to access their website here in a minute, but there's a phone number if you would like to contact them. This is a free tool they have on their website. There's no cost to use it, and if you do need some outside help, this is certainly one of them that I thought would be a great fit. If I were looking for currently, it would certainly be something that I would do. So here's some additional resources. You have the ATCC, which was the American Association of Textiles Chemists and Colorists. These folks, and that's kind of what the IFAI's website was linking you to. Of course, here's the IFAI's direct to their website and all that they have. There's a plethora of information, a lot of divisions within the IFAI. It's a very big organization, and the website really identifies the different divisions of it very well. And if you ever need help navigating that, feel free to reach out to the folks here involved at the IFAI and on their presentation today. IRS tax code, that's one thing that previous, the Intrepid Advisors can help with. People don't realize that it's part of the tax code. It's not a program. It's actually, the IRS has tax code that allows you to take advantage of R&D tax credits that are for you. And if your accountants, if you're CPAs, or if you don't do that, if you don't have anyone, you'd want to find someone like these tax experts have and ask them these questions. Get yourself knowledgeable so you can make sure when you're doing your tax return that if you spend $140,000 of R&D costs that you can calculate, and these tools I've given you today should help you identify those. If you're not taking advantage of those, you're leaving money on the table. Go after that. And then down here, I put a resource as the Consumer Product Safety Commission. I reach out to them often because I want to make sure I'm making a product that meets requirements, and I want to know what they say. They're a federal agency, and I always get in writing from them what they recommend that I do. They didn't require me to do a specific load test, nothing regulatory. I told them I was concerned about shear forces on my frame, and so it's a great, Chad, we're great, you're concerned with that. There's nothing we require. As long as there's no lead paint in your metal frames, then I'm good. So that gave me a great level of comfort. I get that in writing, and now down the road, if there's ever an issue, I can refer back to my communications with the Safety Commission. Again, here is the website to these folks at Intrepid with that great tool. Probably one of the best tools I found online. Feel free to navigate to them. I did get permission to use their map and their website. I always make sure that I clear that with them. They were very happy to offer that, gracious for that. And if you need any assistance, this is their information to go gather more information. And then there's always the National Institute of Standards and Technology. The reason I put this on here is they partner with states. They have programs. We have what's called the CMTC here in California, California Manufacturers Technology Committee. And what they do is they actually help me to access grants or offset training if I want to upskill my employees to be able to do work. Maybe I don't do CNC milling, and for a project I want to, or I want to buy the equipment and do that. There's a lot of offsets there, and NIST works. So you can contact NIST and find out who does that in your state. That's either free or whether it's fully subsidized by a grant. I know there's a lot of training that we get both for employees and they have access to CET. Career technical education organizations that can bring in consultants at low cost or offset costs. And that's another great tool for you to use as well. So I highly recommend you contact them, reach out and find out how or what resources there are locally in your area. Excellent. Well, I left us here at 10 minutes. It was a lot of information, so I do apologize if it seemed like too much too quick. But I tried to cram in as much as I could in this short time that we had. And so now I guess I can open up the floor to any questions you might have.
Chad, that's great. You've really done an amazing job at revealing the complexity of figuring out the cost for prototype development. I would like to point out a couple of additional resources available through IFAI. One is a map on the Makers Division website called Find a Contract Sewer. If you have a prototype ready to go or you're interested in prototype development, that's a great place to look for that for a contract sewing operation. And if you're looking for materials and sourcing, please feel free to take advantage of our Info Central line, where you can email your request or make a telephone call and talk to somebody who will help you locate products for your prototype. We do have a question that came in, and if you're interested in asking Chad a question, please feel free to type it into the control box on the right side of your screen. And this question, Chad, is about the bid process and time. How do you handle situations where a quote is required really quickly to keep you in the bid process while you're still working on the concept? So this company often finds that they are having to come up with a bid or a cost with only about 70% of the information ready just to stay competitive and stay in the bidding process. Do you ever give ballpark pricing when you're working with prototypes?
Yes, and there's the unfortunate reality that your ability to quote it is really going to be predicated on your experience in the past. So being that I have had 20 years of experience in many industries, I know what I'm up against based on the industry. Yes, I do ballparks, and one recommendation I always have is so that you don't really so you have recourse later. I like to take all those phases and I like to quote them out phase by phase. And basically, I can chop up one big project. So if you look at it from the first time I meet with a customer until the end product, I've made a product for them, I chop it up into phases and I let the customer know the phases. I share that with them and I tell them, look, I'm going to estimate there's going to be 7 hours of work here and 3 hours there, and I kind of phase it all out. And then you might get down the road and realize, you know what, there's going to be 4 or 5 more hours I need to draw up this tool that I didn't know I needed to make because your change in the product's design required it. So I always leave myself an out. But yes, we charge $75 an hour for our services. And I can look at a product and I can tell them, okay, phase 3 is going to take this long. Phase 4 is going to take this long. And I literally, if they like what I did for them in phase 4, then we progress to phase 5. And that way, instead of what's one contract, saying, oh, it's a $5,000 prototype, it's dangerous to do that. So I would recommend chopping it all up. Just bite off how much you can chew. If you know what it's going to take for phase 3, give them a quote on phase 3. And then you could tell them, look, I think phase 4 might take this time, but depending on what happens in phase 3, it could be 25% more, 25% less. But what customers like to have is an idea. So if you say it's going to take about 5 hours, but give me 2 or 3 hours plus or minus, we always ask customers, look, I think it's going to take 4 hours. Give me a purchase order for not to exceed 6 hours. That way you've got a slush fund built into it. That typically helps put them on notice that you may be off a little bit, but it gives them a not to exceed. And then what we do is we contact our customer. If we do hit the 6 hours and we need an hour or 2 more, we do it that way. And they seem to like that a lot better. But it gives you an insurance policy that you're not really tied down to 4 hours. You said 4 hours.
Sounds great. I think that answers one of the other questions that came in about whether you fold your costs into the R&D process or into an ongoing production pricing. So it sounds like you're costing things according to the phase of the production. Is that correct?
Yeah, we really have to do it that way because every project is completely different. Phase 4 might take me 5 weeks. Phase 5 might take me a week. And it just really depends on the client, their product, and their team and what they can provide me with. And a lot of times I'm sitting here waiting and I might make 5 or 10 phone calls or emails. That's all time. So yes, I would definitely separate your phases out and just hit it one phase at a time and just make them aware of the whole process up front.
I'm sure it's reassuring to our listening audience that this process is so complex that the questions are not always answered quickly, and that there always seem to be more questions coming up about even with somebody with 20 years of experience. So we have one more question here. What is your opinion of and your experience with a customer who would like the prototype costs to be built into the unit price and be quoted for potential future orders? Have you ever dealt with that before?
We have been requested to do that before. However, who owns the product? What they're asking you to be for them is a bank. And I'm not a bank. I don't want to be a bank. Now we are in the sense that, once I have a relationship with a client and they've filled out a credit application and I've checked their references and I've got 6 months of experience with them and they pay the bills on time, we assess that risk and we are able to assume that risk. But when you have a new project and new client, I always adopt this kind of mentality is I don't want to invest more into their product than they do. And if they're not willing to finance it, that is a red flag for me. And I would highly caution against that kind of project financing, because you might give them things along the way that is your intellectual property and without you, they couldn't have done. What's to stop them? I mean, non-disclosure agreements are only as your ability is to defend it, to defend that. So it is risky. I don't engage in that practice. You would have to assess whether that's something you want to do, but that's a red flag as far as I'm concerned.
Okay, sounds great. Next question is, in your particular business, what percentage of your company relates to projects that emanate from R&D as opposed to your ongoing products and services?
Great question. We currently we are always in R&D mode. We're always designing and engineering for a customer. So it's continuous for us. And I currently have 14 projects on my caseload. My father, who runs this division with me, he probably has about an equivalent number of that. So I would say we probably have about 2 of us working full-time on R&D work all month long out of about 25 people in the admin, engineering, and R&D side of things. So I would say probably 15 to 20% of what we do is related to R&D work.
Okay, so sounds good. Can you talk a little bit, Chad? If anybody else has questions, please feel free to submit them. Can you talk a little bit about when have you decided to outsource something versus create a new tool, or do you have any examples of that?
I do. And what I do is kind of ask some of the questions I revealed today. And that is, do I have the equipment? Do I have a tool that I have a milling machine, but I don't have a 3D CNC machine. So if something can be done better, because if I do it internally and it takes me 3 revisions or 3 goes at it, go at it to make the product function properly, the tool or the jig, then I would outsource it. So I ask a bunch of questions like I showed earlier. Do I have the talent? Do I have the equipment? Do I have the materials? Do I have the manpower to do it? If the project requires me to stand in line with my own, like maybe my silkscreen department's 2 months or 2 weeks out, maybe the silkscreener down the street can do it in a week, and that'll help the project stay on time. So sometimes it's time driven, sometimes it's expertise driven, and sometimes it's asset driven. I don't have the right equipment or the right body for the equipment right now. So those are certain factors that would require me to outsource it. I do have small internal test capabilities with some certain equipment I have, but I don't have lead content testing. So some are actual driven by customer requirements or by test requirements that ASTM set in place. So those are some of the reasons why I would outsource certain parts of the process.
Okay. And then I think we have time for one more question here. And the question is that, do you accept projects that are already designed to be built by your company?
Yeah, pretty much. I would say that happens maybe about half the time. It's probably about right. Someone will already have something designed and they want to come to us, whether it's just to improve it or to relocate manufacturing, or when they find out I have more than just a California facility and I might be more geographically desirable to them. And I think that's a big thing. And the tool that Magda led to earlier, it shows the IFI's website does show all your contract sewers are in your area. And freight, especially if I'm doing a large bulky item like foam or air or something, it does make sense to find a local manufacturer. So yes, we do have people contact us looking just to have us quote their existing design product. And maybe because I'm a different factory, maybe I've got a piece of equipment that allows me to do something like we've got automated robotic cutting machines. Maybe their factory does it and they're having registration problems. And moving to my facility would solve a quality problem for them. And so, yes, we do have people that do reach out to us, and we do that frequently. And that probably represents about half of our workload that we get on a continual basis.
Wonderful. Well, I hope everyone has enjoyed today's webinar. Chad, we thank you so much for sharing your expertise. It's members like you that make our trade association great and our members stronger and more educated. As a final note, be sure and sign up for the other prototype education webinars in this series. And the ones that have already been completed will be available on the Makers Division webpage at ifea.com/makers. So thank you again for joining us today. And Chad, we really appreciate it. Thank you.
My pleasure. Thank you all for joining.